Hello, welcome. In this short video, let us look at an example in which we use Z-transform approach for finding the both impulse response and step response of a given system. So consider the following system characterized by the system equation y of n minus 3 by 4 y of n minus 1 plus 1 by 8 y of n minus 2 equals to x of n. So given this system function or system equation, we want to find its impulse response and the step response. So the goal is to find impulse response and step response. So first let us deal with impulse response. That is, we have to find h of n. So for the first step for finding the impulse response is we have to find h of z. So we can determine the value of h of z or the function h of z by applying z transform to the system equation. So that is, by applying z transform to equation 1, we can write as y of z multiplied by 1 minus 3 by 4 z power minus 1 plus 1 by 8 z power minus 2 equals to x of z. So from this equation we can write that h of z, that is the system function, is equal to 1 upon 1 minus 3 by 4 z inverse plus 1 by 8 z power minus 2. Now we can factorize this denominator so that it is convenient for finding the inverse z transform. So it can be factorized as 1 minus 1 by 2 z inverse multiplied by 1 minus 1 by 4 z inverse. Now part 2 of this finding impulse response h of n is to find the inverse z transform of h of z. So that means we have to find the inverse z transform of 1 by 1 minus 1 by 2 z inverse multiplied by 1 minus 1 by 4 z power minus 1. So for that purpose we apply partial fractions so that we can decompose this z transform. So we write it as a by 1 minus 1 by 2 z inverse plus b by 1 minus 1 by 4 z inverse. So to find the constants a and b, we can compare the numerators on both sides. So first, comparing the constants, we have a plus b is equal to 1, and by comparing the coefficients of z inverse, we have minus 1 by 4a minus 1 by 2b is equal to 0. That means a plus 2b is equal to 0. So by putting a is equal to minus 2b in the first equation, that is by substituting a is equal to minus 2b, we can clearly see that we have minus b is equal to 1 or b is equal to minus 1, and from this equation a is equal to 2. So the impulse response h of n is inverse z transform of 2 by 1 minus 1 by 2 z inverse minus 1 by 1 minus 1 by 4 z inverse. Therefore h of n will be equal to 2 times the inverse z transform of 1 by 1 minus 1 by 2 z inverse. That is, basically we are assuming that we are talking about causal systems. So the ROC will be z greater than 1 by 2. It is ROC is the region outside the circle of radius 1 by 2. In that case, we'll have causal inverse z transform. So 2 times 1 by 2 power n u of n. That means the inverse z transform of 1 by 1 minus a into z inverse is a power n u of n. So based on that definition, we have 2 times 1 by 2 power n u of n. And for the second one, it is minus 1 by 4 power n u of n. So that is the impulse response. It is 2 times 1 by 2 power n minus 1 by 4 power n u of n. That is the impulse response of the system. Next, now we want to find, now the next step is to find the step response. That is step response. So the step response S of n is defined as the summation of h of k, where the values of k are from 0 to n. Basically, we are assuming that h of k corresponds to a causal system. So summation is from 0 to n. So and based on the result, S of n is equal to summation 2 times summation k is equal to 0 to n 1 by 2 power k u of k minus summation k is equal to 0 to n 1 by 4 power k u of k. And since u of k is equal to 1 for all values of k greater than or equal to 0, so this is 1 and that is also 1. So S of n is 2 times the summation k equal to 0 to 1 by 2 power k, which is basically a geometric series. So the value is 1 minus 1 by 2 power n plus 1 upon 1 minus 1 by 2. And for the second sum, it is minus of 1 minus 1 by 4 power n plus 1 upon 1 minus 1 by 4. So upon simplification, S of n will be equal to 4 times 1 minus 1 by 2 power n plus 1 minus 4 by 3 minus 4 by 3 multiplied by 1 minus 1 by 4 power n plus 1. Upon further simplification, S of n becomes S of n is equal to 8 by 3, that is simplifying the constants, and then minus 4 times 1 by 2 power n plus 1 plus 1 by 3 multiplied by 1 by 4 power n. And since the definition of S of n says that it is summation from of k equal to 0 to n h of k, that means S of n is non-zero only for n greater than or equal to 0. Therefore, S of n means S of n is 8 by 3 minus 2 times 1 by 2 power n plus 1 by 3 1 by 4 power n multiplied by u of n. So that is the step response. So to summarize, we have looked at the system given by the system equation y of n minus 3 by 4 y of n minus 1 plus 1 by 8 y of n minus 2 is equal to x of n. We want to find both the impulse response and the step response. So first we find the impulse response. So in this part, the first step is to find h of z, that is the system function. The system function can be determined by applying z transform to the system equation. So the system function is found to be h of z equal to 1 by 1 minus 3 by 4 z inverse plus 1 by 8 z power minus 2. And we factorize this system function for convenience of finding the inverse z transform. So the factors are found to be 1 minus 1 by 2 z inverse and 1 minus 1 by 4 z inverse. So h of n is equal to inverse z transform of this z transform. So by applying partial fractions approach, we found that h of z is inverse z transform of the combination of these two fractions, that is 2 by 1 minus 1 by 2 z inverse minus 1 by 1 minus 1 by 4 z inverse. So upon applying the inverse z transform and assuming that we are talking about causal systems, h of n is found to be 2 times 1 by 1 by 2 power n u of n minus 1 by 4 power n u of n. And the step response S of n is basically summation of the h of n, that is h of n is k equal to 0 to n, summation k equal to 0 to n h of k. That means upon substituting the result for h of n in the definition of S of n, we found that S of n is indeed equal to 4 times 1 minus 1 by 2 power n plus 1 minus 4 by 3 times 1 minus 1 by 4 power n plus 1. And this is only valid for, that is it is only non-zero for n greater than or equal to 0 based on the definition of S of n. So S of n is finally found to be 8 by 3 minus 2 times 1 by 2 power n plus 1 by 3 into 1 by 4 power n u of n. Thanks for watching.